Hello everyone. In this video, we will see the type 2 of improper integrals and how do we find the solution for them. Okay, so what we will see? We'll see that here the integrand, the function, your function which you have to integrate is unbounded over the integral. Then how do we evaluate this integral? Why we are saying it is unbounded over this interval? Because we have to find the integral from -2 to 1. Okay, and if we look at this function, if we substitute the denominator to 0, we get x is equal to -1, which lies in between this interval. So the function become unbounded over the interval of integration, and it is called type 2 improper integrals. Let's see how do we solve them. So here, what you need to understand is how and at which point the function is becoming unbounded. So let's see the first integral. So what will happen here? If you look at the interval of integration is 0 to 1. Okay, in this example. If we substitute the denominator equal to 0, what we will get? Cube root of x 0. This is possible to 0 only if x equal to 0. So what is happening? The function is becoming unbounded at x equal to 0, which is the lower limit of integration. Okay, what is the other scenario? Other scenario, let's take this example number 2. So this integral is from 0 to 5, x equal to 0 to 5. Now if we look at the denominator, 25 minus x square equal to 0. So this gives you x square equal 25. That gives you x is equal to 5 and minus 5. Minus 5 is not the range of the integral, but see x equal to 5. So here the function become unbounded at the upper limit at this point. And the third situation is, let's see, the third example, say 0 to 2. So your limit of integration is 0 to 2. Now, if we look at the denominator, x minus 1 to the power 1 power 3 is equal to 0. This gives you x minus 1, 0. That is x equal to 1. So what is happening? It's neither the lower limit nor the upper limit, but instead it's a point 1 which is in between the middle value. Okay, so in this video we will see how to solve these three type of questions. Let's see this example. So again, let's check if any of the limit is infinite. No, so it's not a type 1 of improper integral. What we have to check, we have to keep the denominator equal to 0. This gives you x equal to 0. So it means the function is bounded at 0 because you are integrating from 0 to 1. So at this point, the function integrand is becoming bounded. So what you do in this case? Again, in this case, we will make use of limit, similar to what we did in the type 1 of improper integral. So we rewrite it as limit, as lower limit at lower bound is the term where the function is in unbounded. So we write a goes to 0. We change this. A to 1 dx over and cube root of x, we can write x power 1 over 3. Okay, so what we did, in place of 0, we replace it by a. Then this become your normal integral, integrated. So to integrate, what we will do, we will bring this term to the numerator. So this gives you limit a approaches to 0, integral from a to 1, x to the power minus 1 over 3 dx. So what you can do, you can use again the rule. So this gives you limit a goes to 0, x to the power minus 1 over 3 plus 1 minus 1 over 3 plus 1 from a to 1. This gives you limit a goes to 0 minus 1 over 3 plus 1. This gives you 2 over 3. So you will have here 3 by 2 x to the power 2 over 3. And the limits for x is from a to 1. So it means you will be replacing this x one time by 1 and then by a. So this gives you limit a approaches to 0. 3 by 2. When you replace x by 1, it is 1 to the power 2 by 3 minus a to the power 2 by 3. A power any number gives you always, 1 power any number gives you 1. So this gives you 3 by 2 into 1. That gives you 3 by 2 minus 3 by 2. Just replace this a by 0. So what you get here? 0. Here this is 1. Okay. 0 to the power 2 by 3. So 0 power any number is 0 and 0 multiply any number is 0, giving you the value of integral as 3 by 2. Okay. So this is how we solve it. Let's see how do we answer if we have this question. So again, first you have to check is it improper integral or not. So your limit of integration is from 0 to 2. Area of integration is for 0 to 2. Interval of integration. And when you put x power 3 to 0, you get x equal to 0. So it is unbounded at 0. So again, rewriting it as limit a approaches to 0, integral a to 2 dx over x power 3. Okay, this gives you limit a approaches to 0, integral a to 2 x power minus 3 dx, which on integration gives you x power minus 2 over minus 2 from a to 2. Substituting the limits, limit a approaches to 0, what you get? 1 over, because this term you can write it as x to the power minus 2 can go in the denominator. So you can write it as 2x power 2, this term. So this gives you minus 1 over 2 into 2 power 2 plus 1 over 2 into a power 2. Okay, so this gives you the first term will become minus 1 over 8 plus when you replace this a by 0, what you will get 1 over 0. 1 over 0 means infinite. This term become infinite. Infinity plus anything is also infinite. So we say that this integral 0 to 2 dx over x power 3 diverges. It's having an infinite value. Okay. Let's see how we can solve this question. So in this example, your interval of integration is from 0 to 2. Let's check the integrand. So if x minus 2 is equal to 0, this gives you x equal to 2. So it means the upper limit is the point where the function becomes unbounded. So we rewrite our integral as limit. Again, you can use a or b, it doesn't matter. B goes to 2, say 0 to b, dx over x minus 2. Now this integral becomes definite integral. Integrating it. So for this, you can use the law of integration that says that dx over ax plus b is 1 over a ln of mod of ax plus b plus c. What we did is whatever is the coefficient of x, we divide by that. So using that rule, this gives you ln of mod of x minus 2, limit is from 0 to b. So this gives you limit b approaches to 2, ln of mod of b minus 2 minus ln of 0 minus 2. Now replacing b 2 by 2, what you will get? In the first, you will get ln of mod of, in place of b we are writing 2 minus 2 minus ln of, there is no b, mod of minus 2. So this basically gives you ln of 0, and ln of 0, if you know, it is infinite. So again, we say that this integral diverges. Okay, so we say that integral 0 to 2 dx over x minus 2 diverges. Let's take this example. So here your integral is over the interval 0 to 2. Let's check for the unboundedness. We have y minus 1 to the power 1 over 3 equals 0. This gives us y minus 1 equal to 0. That is y equal to 1. Y equal to 1, which is in the middle of the given interval. Okay, so at this point, the function becomes unbounded. So in this case, what we have to do, we will be breaking our integral from 0 to 2 as 0 to 1 plus 1 to 2. Okay, and then what will happen? In the first integral, the function become unbounded at 1. That is the upper limit of integral. And for the second integral, the function become unbounded at the lower limit. Okay, so our question now become, if we rewrite it as integral 0 to 2, 1 over y minus 1 to the power 1 over 3 dy equal integral 0 to 1, 1 over y minus 1 to the power 1 over 3 dy plus 1 to 2, 1 over y minus 1 to the power 1 over 3 dy. Okay, so you see here we are solving the same integral. So let's do a little thing over here, like let's calculate the value of this integral. 1 over y minus 1 to the power 1 over 3 dy. How we can evaluate? We can integrate it as y minus 1 to the power minus 1 over 3 dy, and this will give you y minus 1 to the power minus 1 over 3 plus 1. That gives you 2 by 3. And in denominator you have 2 over 3. So this 3 goes up. So you can write it as 3 over 2. Okay. So this we did separate so that we can use the values here directly, and then it will become easier. Now, let's say this is your part 1, this is your part. Solving 1. What is it? Integral 0 to 1, 1 over y minus 1, 1 power 3. Yes. At this function, it is unbounded at the upper limit. So we can rewrite it as, yes, limit a goes to 1, 0 to a, 1 over y minus 1 to the power 1 over 3 dy. And the value of this integral from here, we'll use it. So this gives you limit a approaches to 1, 3 by 2, y minus 1, 2 by 3, 0 to a. Then what you'll do here is change y. First time by a and then by 0. That gives you limit a approaches to 1, 3 by 2, a minus 1 to the power 2 by 3 minus 0 minus 1 to the power 2 by 3. And then what you have? You have a approaching to 1. So this will become 1 minus 1. This gives you 0. And this will remain same. So this gives you the final value of part 1 as minus 3 by 2 minus of minus 1 to the power 2 by 3. Okay. Now solving this second part. So what is it? Integral 1 to 2. What is it? Dx over x, sorry, not x, it's in y, dy over y minus 1 to the power 1 over 3. Let's check it. Yeah, this is 1 to 2. So here it is unbounded at the lower limit. So we can write it as limit. Let's see, b approaches to 1. You can use same a because it's the same thing. Y minus 1 to the power minus 1 over 3 dy, which gives you limit b goes to 1. This will be 3 by 2, y minus 1 to the power 2 by 3 from b to 2. Change b, y, 2 and b. This gives you this value b, 2 minus 1, okay, and b minus 1. 2 minus 1 become 1. So basically the first term becomes 3 by 2, 1 to the power 2 by 3. Minus, when we replace b by 1, you get 1 minus 1 to the power 2 by 3. So basically this term becomes 0. So here you get the answer as 3 by 2, 1 to the power 2 by 3. This is for part 2. Okay, so your main integral becomes addition of 1 and 2 from here. Okay, so your integral 0 to 2, 1 over y minus 1 to the power 1 over 3 dy become equal to the value of first integral from here, which is 3 over 2 minus of minus 1 to the power 2 over 3 and plus the second one 3 by 2 1 to the power 2 over 3. 1 to the power 2 over 3 is 1, okay, and then you can simplify.